Welcome to the very first episode of the Energy Forum. I'm Ken Medlock, Senior Director of the Center for Energy Studies at the Baker Institute at Rice University. The energy landscape is constantly evolving, and today it faces an enormity of challenges. From dealing with climate change and the race to decarbonize, to shifting and growing global energy demands, as well as grappling with geopolitical conflicts that threaten supply chains, it's clear the need for informed dialogue is more critical than ever. That's exactly what this podcast is about, offering expert perspectives, thoughtful analysis, and actionable ideas to navigate these complexities. In each episode, we'll explore key programs and initiatives covered at CES, from energy and materials transitions to sustainability, new technologies, energy market developments, and geopolitics, breaking down how these forces shape the way we produce, consume, and think about energy. So if you want to hear more about how policies around energy are shaped, why gas prices seem to fluctuate, and why you keep losing power after a storm, stay tuned. We've got you covered. Joining me today is Michot Foss, Fellow in Energy, Minerals, and Materials. We'll unpack her latest research on critical minerals and materials and the challenges they present for the future of energy. Michelle, let's start with something that's very topical and often in the news, lithium. The whole world is racing to secure lithium supplies. Right now, only a select few countries are actually producing it. And of course, as you've often pointed out, China is sort of leading in its processing and handling of lithium, ultimately as an input into electricity storage technologies, batteries. But here at home, we actually do have some opportunities. There is resource that's available. One of the things that has been sort of prominent in the news is the movements of companies like ExxonMobil to extract lithium from brines. But there are other opportunities as well. I wonder if you could sort of unpack what's going on in the lithium supply space in particular and what role the U.S. actually can play in that realm.
So right now, best estimates for what we call lithium carbonate equivalent, LCE, which is kind of the common form of lithium that everybody looks at. It's like light sweet oil, the light sweet oil equivalent for lithium. The United States produces around 2,000 tons, but it's not reported by the USGS because the USGS, by law and authority, can't report data that's considered proprietary to operators. But the best estimates is that we produce about 2,000 tons out of the total roughly 350,000 tons worldwide. And probably that doesn't sound like a whole lot to people because of all the news about lithium, but only a small amount of lithium goes into every battery that's out there. Obviously, the bigger the battery, the more lithium there is. The challenge, of course, is the idea that demand for lithium will grow and where supply will come for that demand. In the United States, we have a lot of lithium. Lithium really, when you look at the periodic table of elements, lithium is one that was original to the formation of the universe. So it has that unique attribute. It's like gold in the ocean. It's everywhere. So the problem is concentrating it. We've got different projects that look at different resource occurrences. So, for example, one that's been in the news a lot, Thacker Pass in Nevada, that would be lithium extracted from mined rock, clay-based rock. We have the Salton Sea in California, which is rich in lithium. And we have the brines that you mentioned that are below surface in very highly saline, high total dissolved solid aquifers that contain not just lithium, but other minerals of interest. Where Exxon and others are looking in Arkansas, those brines are very rich. They're in a formation that we know is the Smackover. Historically, people have produced bromine from those brines, so we know that you can extract the minerals from them. The challenge, like everything, is commerciality. Can you produce and extract brine fluids, separate the lithium, process the lithium, deliver it to a customer, and beat the cost of basically a Chinese supplier, since they are the largest in the world today, which is the number one problem for U.S. mining anyway, is being cost competitive.
You just leaned into effectively the entire supply chain. And this translates across multiple mined commodities. It's not just a lithium phenomenon, but processing is something that often comes up, particularly when we talk about China. It's not so much the production of the raw material as it is the processing and ultimately integration into the supply chain that leads to customers receiving electric vehicles or in-home storage or commercial scale batteries, utility scale batteries. Can you talk a little bit about the challenges we face in the United States with regard to entering in a commercially successful way, that part of the value chain, which is really the processing and handling piece?
So lithium is a little bit of a different story than other metals. And China, bearing in mind when we think about this, the differences between our country and China in this regard, at one time, not for lithium, because back in the 1970s and 80s, nobody really cared about lithium except for pharmaceutical uses. It's only been with the advent of rechargeable lithium-ion batteries that we really, have become interested in that particular element. The Chinese invested in capacity, and we didn't. And so, when it comes to that particular commodity, lithium production from Chile, Australia, a few other places is aggregated by Chinese processors. And you've got advantages in labor costs, you've got advantages in energy costs and other things. So you come over to the United States, for that particular commodity, it has to be processed to the right form, the right quality for customer needs. And the cost of doing that here is going to be more expensive. Our labor costs are higher. Our energy costs, while competitive and cheap, are going to be more expensive. Other things about the supply chain are more expensive. When you look at other metals, the story is actually worse. So if you think about a lithium-ion battery, there's a lot of other stuff in that battery besides lithium. There's nickel, manganese, cobalt, copper, a lot of other materials that go into the actual battery components themselves, the packaging, the wiring, and a lot of those metals we either don't produce them, or if we do produce them, we tend not to process them. And that is a consequence of a long history of preferences that emerged with regard to managing environmental issues, dealing with hazardous materials, in some cases, dealing with hazardous materials from early days of the mining industry, cleaning up those mine sites, and other things. Today, to try to build processing to process metals other than lithium that have hazardous materials associated with them, getting through all of the requirements, environmental requirements to do that, are really challenging, really, really challenging.
This actually raises a point that it's a great segue into the next thing I was going to ask you. You recently released a pretty significant, very dense research report, Minerals and Materials Challenges for Our Energy Futures. You've kind of touched on some of the challenges that are in front of us, but I'm going to take it from this is why we are where we are today to as we look forward, right? What are the challenges that we face when we start thinking about a world, quite frankly, as you outline very aptly in the report, that is much more materials intense?
Mm-hmm. So I actually came up with 9 challenges, and so far I have had universal agreement, and they incorporate other things that people tend to focus on, like workforce. And, do we have sufficient labor for the industry, and not just for mining and minerals processing, but also for manufacturing, for all of the stuff that we have ambitions to build. So the point about processing, competitiveness, how competitive is the United States for being able to get some of these things done? And we've really lost a lot of ground on that front because we're a high-cost location in a lot of ways, and we have a lot of regulatory hoops. It takes a very long time to reach operation for new projects or even brownfield projects if you're using locations that have been industrial sites before. So that's a project cycle time challenge. We have market challenges because all of these commodities are very dynamic in terms of price. When you start planning a project, you may be expecting a price for your commodity based on what you understand or understood about the market to be one thing, and by the time you're in operation, of course, it can be quite different. Managing through that price volatility is really challenging. And a lot of these things, whether it's those 3 or the big picture on sustainability, how to build raw materials businesses that satisfy all of the expectations that we have for sustainability, or dealing with geopolitical risks, because to the extent that we're going to continue to rely on international suppliers, there are a lot of concerns about that. How does business get conducted in those countries? How fragile are those governments, and so on? Those things can be addressed, but you think about this, 9 challenges. I mean, this is going to take a long time. And so expectations, time horizons, people are really off, I think, in terms of thinking about the level of effort that it's going to take to both correct things that got us to this point where we are a much smaller part of the global market when it comes to raw materials than we used to be. We don't have to be the largest producer, but we have to have a certain amount of competence. But just to get back to that point is going to take a lot of effort, a lot of years, a lot of commitment. Honestly, I don't really see it out there.
A lot of education and training.
A lot of
too,
education and training.
Yeah,
yes,
absolutely.
Yes.
So the idea of a more materials-intensive energy system really is daunting without a doubt. What role does carbon play in all of this?
So this is an interesting one. And by the way, I'm going to put you on the spot in this recording. And a point that you made in that very dense report when I was working on all of these ideas, this point of materials intensity and dematerialization is one that we need to work on. We probably need to work on this together. We need to work on it within the Center for Energy Studies, because when you think about advances in energy technology, you want efficiency improvements. You don't want to give up ground. So what we want to do is we want to move forward with technologies that actually don't require as much, right, per unit of energy produced. So I think that's an important thing to bear in mind in all of this. And you take that over to the carbon side, you know, in this huge debate that we're having about whether we can actually spawn a mining renaissance in the United States, we have an existing carbon footprint that did get preserved. So from the mid-1980s, while the mining industry, the metals businesses were deteriorating, we actually were going the other way when it came to our carbon businesses, especially hydrocarbons, oil and gas. So we've got a footprint that we might be able to do some other things with. A lot of the materials that human beings require come out of the hydrocarbons value chains. So we can think about capturing those materials and maybe bringing them into some other uses in ways that might reduce the need for some of the materials that we don't extract in the mining industry today. And you're supposed to say, like, what are those?
You jumped on there.
So at Rice University, one of the
Yes.
inventions here is carbon nanotubes. And so for listeners, think about buckyballs. Most people are familiar with that expression or what that is. Fullerenes. The idea of a carbon nanotube at the atomistic level can link carbon atoms. A sheet of carbon atoms that we call graphene can get rolled into a tube. And all sorts of wonderful things happen when you make a tube of carbon atoms. You can move electricity, for instance. You can exchange heat. You gain strength, tensile strength. So carbon nanotube materials can be as strong as steel.
Massive flexibility.
Massive flexibility. It's amazing to have something that's as strong as steel, but is flexible when it's in fiber form, like in a textile, is like Gore-Tex that people are familiar with in ski parkas and stuff like that, outdoor gear. So if you can do all of that with carbon nanotubes, well, think about like what goes under the hood of a car today in a battery electric vehicle that we're trying to make. A lot of copper to move electricity around between the battery and other components of the vehicle, keep the powertrain working, all that kind of stuff. And that weighs a lot. It adds a lot to the weight.
One of the biggest impediments to efficiency is weight.
Exactly. Right. So what if you could replace the wire harness in a vehicle that is currently copper with carbon nanotube material and get the same performance when it comes to powering the vehicle, powering all of the systems in the vehicle? So that's an idea that's out there, and you can do that with the current carbon footprint and even a smaller portion of the current carbon footprint, and use an element that's ubiquitous on Earth.
Carbon is the building block of pretty much everything on the planet.
Yes,
so.
Including us, right?
It's a novel idea, right?
It's a novel idea.
Yes.
That's right. And you know, when you go into the mining industry, you talk to people about this, it's really interesting. So folks who have been around the industry a really, really long time, the senior people, the seers out there, they know this is coming, actually. They know that the next stage of metals competition and displacement is going to come from advanced materials like this. So when you think about what you're going to invest in as a mining company, it's got to be a really high quality investment that will continue to supply the amount of metal that you're going to need going into the future. But you know that at some point your product is going to become less competitive than other things. And so we're just going to continue this decades-long, maybe century-long process of displacing metals with other materials, plastics mainly, composites.
It's a great place for me to make the following statement and ask you for some final remarks. But a lot of what we're referring to in this conversation fits under the umbrella of our Materials Transitions Initiative. And Michelle's research is certainly right at the core of a lot of that. So definitely watch for her research. I'm going to highly recommend you check out the report that was published just a couple of months ago now on our website. But also stay tuned because we'll be revisiting a lot of these topics in a lot more detail in the coming months. Michelle, final thoughts?
Well, I like yours that you always use all the time, that energy transitions will reflect where you are in the world, locationally, geographically, and there will be many different versions. We don't know which one, and there's going to be more than one. Several things are going to happen at once. So it's not one energy transition, it's multiple transitions as people test and use different things. I think those are important thoughts for people to remember. And then the materials transition idea, every advance that we've made as human beings has involved advances in materials. A lot of it has been the same. So people love talking about the hierarchy of energy use from wood to coal to oil to gas, right? It's all carbon. But the key thing is it's come in different forms, which has different implications in terms of how you use it, what you do with it. And I think that's important for people to remember as well.
Absolutely. Thank you so much. The Energy Forum is brought to you by the Center for Energy Studies at the Baker Institute for Public Policy at Rice University. This episode was produced by Maram Hijazi. AV production was led by Kevin Young. Be sure to visit us at bakerinstitute.org/center-energy-studies to learn more. Thanks for listening.